So Newton's law of cooling. So it states that the rate of change of temperature, capital T, of a hot body is proportional to the difference between T and that temperature Ts of the surrounding medium. Okay, so like air, water. So the differential equation is dt by dt k is equal to minus lambda into T minus Ts. Okay, where T is the temperature of the body and Ts is the temperature of surrounding medium. Okay, just I will show you. Okay, I think I closed the. Okay, okay. Yes, here. So that's a history and applications. The temperature of many body can be modeled using differential equations. Newton's law of cooling or heating states that the temperature of a body changes at a rate proportional to difference in temperature between the body and its surrounding medium. So it is a reasonable accurate approximation in some circumstances. More precisely, let T denote the temperature of an object and T naught the ambient temperature. If T denotes time, the Newton's law of cooling states that dt by dt equal to minus k into T minus T naught. So I took a Ts, here it is given T naught. So I took lambda, here it is a k. So where k is a positive constant. If the object is much hotter than its surrounding, okay, this T is much bigger than T naught. So T minus T naught is large and it is a positive. So if it is large and the positive means dt by dt is uh, negative. It's a negative number. So okay, so it is large in negative. Okay, so that the object cools quickly. Suppose if the object is only slightly hotter than its surrounding, then T minus T naught is small and positive. So, and the object cools slowly. Okay, for example, a cup of hot coffee will cool more quickly if you put it in the refrigerator. Okay, some of the problems are here. Okay, maybe I will give you these problems are practice problems. Okay, now I will go to the slides. Okay, so this is the differential equation. We have dt by dt equal to minus lambda into T minus Ts. Okay. Now the first problem is a cup of coffee at 80 degrees Celsius is placed in a room with the temperature 20 degrees Celsius. Okay, and it cools to 50 degrees Celsius in 5 minutes. Find its temperature after a further interval of 5 minutes. Also find the time at which the temperature of coffee will come down further by 35 degrees Celsius. So solution. So before going to the solution, just I will write here what is the surrounding temperature Ts. Ts is 20 degrees Celsius. Okay, and initially what is the temperature of a cup of coffee? T of 0 equal to 80 degrees Celsius. Okay, and then and then T of 5. After 5 minutes, it cools to 50 degrees Celsius. So this is also given the question. Okay, so we need to find a time at which the temperature of coffee will come down to by 35 degree. That is, we need to find T of T equal to 35. So when capital T equal to 35, you need to find the small t. That is a time t equal to 35. So we need to find the temperature of cup of coffee. So this is the okay. So this is given here in the question, and we need to find this. So once you understand this, then you can easily solve the problem. Okay. So let the temperature at time t be capital T. So given the surrounding medium is 20, surrounding temperature is 20 degrees Celsius. So by Newton's law of cooling, or the differential equation of cooling, is dt by dt, okay, minus lambda into t minus ts, t minus ts. So this implies dt divided by t minus ts, which is equal to minus lambda into dt. Okay. So now, if you integrate this, so if you integrate this, you'll get log t minus s, log t minus ts is equal to minus lambda t plus log c. Okay. So from this you have log of t minus uh, ts minus log c equal to minus lambda. Okay, so from this we have log of t minus ts by c equal to minus lambda t. Okay, so from this we have t minus ts divided by c equal to e power minus lambda t, or t equal to ts plus c into e power minus lambda. So from the next problem onwards, I will start from this equation, because this is common to every problem. So just I will write by Newton's law of cooling, we have T equal to Ts plus C into e power minus lambda t. Okay. Now we know that Ts, that is a surrounding temperature, is 20 plus C into e power minus lambda t. So okay, I call this is equation 1. Okay, now, so what is given in the question? Next data. At initially, that means at time t equal to 0, a cup of coffee at 80 degrees Celsius is placed in your room. So that means initially the temperature is 80 degrees Celsius. That is when T equal to 0, capital T equal to 80 degrees Celsius. Okay. So now, if you substitute this in equation 1, okay, 80 equal to 20 plus C into e power 0. So this implies C equal to 60. Okay, C equal to 60. Now substitute C equal to 60 in 1. So equation 1 implies, what is equation 1? Left hand side, T equal to Ts plus C is 20 into e power minus lambda T. Okay, I call this is equation number 2. Equation number 2. And one more thing they gave in the question is to 50. That is find the find. We need
Sir,
to find.
C is equal to 60, sir.
C is 60. Yeah. Oh, so I put 20. Okay. Thank you. C is 60. Okay. Now, okay. And T of 5. Okay, and it cools to 50 degrees Celsius in 5 minutes. That is at a T equal to 5, the time equal to 5, the temperature is 50 degrees Celsius. So when T equal to 5, the temperature T equal to 50 degrees Celsius. So using this condition in equation 2, we have 50 equal to okay, Ts is what? Ts is, we know that Ts is 20. You can write 20 here. Okay, I think here I write 20. Okay, so Ts is 20 plus 16 to e power minus 5 lambda. So now this is 30 divided by 60 equal to e power minus 5 lambda. So this implies e power minus 5 lambda equal to half. So this implies e power minus lambda equal to 1 by 2 whole power 1 by 5. So using calci, please check it, 0.8706 I have. So if there is any change, please inform me. So once you got e power minus lambda, so equation 1 is what? T equal to 20 plus, okay, 20 T equal to 20 plus C is 60 into e power minus lambda T. E power minus lambda is 0.8706 e power minus lambda whole power T. Okay. Now we need to find, okay, when uh, T equal to I think 35. T equal to 35. 35 degree. We need to find the time. So the time. So I need to find the time. So substitute in this equation T equal to 35. So t equal to 35. You call
Sir,
some
in the
key number.
question, it is given that further by 35, sir. So,
Uh, Find its temperature after further interval of 5 minutes.
no,
Uh,
sir.
uh,
Here it is
Please
given
tell.
that the temperature of coffee will come down by further by 35 degrees. So, 50 minus 35, 15 degrees T.
Uh, okay, okay. You are telling that it is 45, something 15.
50 and came down by 35 means 50 minus 35. So, 15 degrees T.
15 degrees you are telling. Actually, it will come down further by 35 degree. Uh, no, I think here, okay, what I understand your point, but here they mean that, okay, uh, okay. Also find the time at which the temperature of coffee will come down. What is here? It cools to 50 degrees Celsius. Okay, here it is correct. Okay, so 80 to 50. And also find the time at which the temperature of coffee will come down further by 34 degrees. Okay, so if you take further by 35 minutes, I will take 15. Okay, so then we need to find t equal to what? So if you substitute t equal to 15, what happened? Substitute here equation number what? Equation number 3. Equation number 3. 15 equal to 20 plus 60 into e power sorry 0.8706 whole power t. So this is equal to minus 5 by 60 equal to 0.8706 whole power t. So this is equal to this is 0.8706 whole power t, which is equal to minus 1 by 12. So can you tell what is t? If you take log on both sides, okay, t log base 10 uh, 0.8706, which is equal to log base 10 minus 1 by 12. So this is equal to, so can you tell t value using calci?
Sir,
Uh,
sir, denominator 0.0601, sir.
Denominator is 0.06 uh, 0618. I got it. 0.0618. I'll check it again.
Sir, numerator 1.079,
Please
sir.
write. I got the denominator is uh, whether it is a positive or negative denominator.
Negative, sir.
Negative.
Negative, yeah. negative. Okay, 0.0618. So please check it. Please tell the numerator. You can't find the log of a negative number. So what happened?
It's 1.079.
1.07. How you calculate Yashashni? Please tell.
No, sir, sorry.
Because using calculator, log of negative number, actually you can't find it. Okay, well, because if you take log on both sides, you'll get what? Log base 10 minus 1 by 12. Okay, well. So for you are getting log of a negative number. So theoretically it is possible. Theoretically it is possible means using complex numbers, uh, you can find the log of negative numbers, but using calculator you can't find it. So I will change my problem is, okay, I will change my problem is, so okay, instead of find the time at which the temperature the coffee will come down by further 35 degrees, just I will take uh, the temperature of we should find the time at which uh, the temperature of coffee will come down by 15 degree. 15 degree.
Sir,
Yeah, please tell.
can we write like log of minus 1 by 12 as log minus 1
It's
minus
not
log?
audible.
So can we write log of minus 1 by 12 as log minus 1 minus log 12?
uh, Log of
Like using the log m by n is equals to log m minus log n formula. Sir.
okay, so you are writing log 1. Okay, but here you have minus sign.
Log of minus 1, is it a 0, sir? Or is that also error?
Yeah, that's why I told that. So log of negative number is you can't use it, you can't find it. Okay, so thank you for your try, but there is a problem in the question. Okay, there is a problem in the question, but initially I thought that 35 degree. Okay, but some, I don't know the name, somebody told that okay, what he says is correct, because find the time at which the temperature of coffee will come down by further by, okay, further by 35 degree means it is 50. Okay, so if it is exactly 35 degree means, okay, I will take 35 degree. So if I take further by 15 degree means now it is 35. Now it is 35. So if t equal to 35, what is the small t? So if t is 35, uh, this is actually uh, 15. Okay, 35 minus 20, 15 by 60. So 50 is 15 by 60 means 1 by 4. 1 by 4. And okay, so now take log on both sides. Okay, now log on both sides. So t log base 10, 0.8706, it is equal to uh, log base 10 1 by 4. Now you can write this is minus log of 4. You can write this is minus log of 4 using the properties of logarithm. So now from this t equal to minus log 4 base 10 divided by log base 10 0.8706. So now find t. So please tell what is the numerator and what is the denominator using calci.
Numerator 0.602, sir.
Okay, 0.6206 I am getting. So please check it once again.
So
I got
denominator is minus 0.06.
minus okay 0.0 minus 6.018. I got it. Okay, again I will do
1.004,
it.
sir. Yes, sir.
Okay, yes, this is equal to 10.0044. Okay, so t is approximately equal to 10 minutes. Okay, so thank you. And still, if you have any problems or doubts, you can ask to me. Then I will go to the next problem. Okay. The second problem. Okay. The second problem is please read the problem and try to answer. Okay. Yeah. The body originally at 80 degrees Celsius cools down. So I'll put power. Power is. So please go through the problem and try to solve it. Okay. So your body originally at 80 degrees Celsius. That means T of 0 equal to 80. It is given. T of 0 equal to 80 degrees Celsius. And cools down 60 degree in 20 minutes. So that is a T of 20 equal to 60. Okay, the temperature of the air, that is a surrounding temperature, Ts is equal to 40. So the question is to find the temperature of the body after 40 minutes. That means when T equal to 40, what is the temperature? So this is the question. So in the previous column, temperature is given, we found the time. Here the time is given, we need to find the temperature. Okay. So I'll start directly by Newton's law of cooling. Okay, Newton's law of cooling. So T equal to Ts plus C into e power minus lambda t. So this is equal to T equal to Ts is 40 plus C into e power minus lambda t. Okay. Now what is given at a t equal to 0 is given at a t equal to 0, capital T is 80. So 1 implies 80 equal to 40 plus C into e power 0 1. Okay, this implies a C equal to 40. C equal to 40. So substitute C equal to 40 in 1. So T equal to 40 plus 40 into e power minus lambda t. I call this is equation number 2. So now what is given the question after 20 minutes? Okay, so t equal to 20. When t equal to 20, the temperature is 60. So equation 2 implies, okay, so 60 equal to 40 plus 40 into e power minus lambda t. So 40 minus 60 minus 40 is 20. 20 divided by 40 equal to e power minus lambda t. So this implies e power minus lambda t equal to half. But t is what? T is 20. Yeah. Okay, 20. Okay, so 20 lambda e power minus 20 lambda. So here also e power minus 20 lambda. Okay, that is equal to 1 by 2. Okay, so now from this we have okay, I'll find lambda. Okay, so e power 20 lambda equal to 2. Okay, this implies 20 lambda equal to log base e 2. This is 2. So this implies lambda equal to log 2 base e by 20. So please check it, lambda equal to this is log 2 is base e is 0.693 using calculator. Please verify. So divided by 20. So lambda equal to 0.0347. So this is your lambda. Now once you got the lambda, you can substitute in equation 2. Okay, so equation 2 implies that t equal to 40 plus 40 into e power minus lambda t. E power minus lambda is 0.3747 into t e power minus lambda t. Okay, up to this is okay. Now I call this is equation number 3. So now we need to find the temperature when uh, when small t equal to 40 minutes. Okay, so I need to find the temperature. So T equal to equation 3 implies 40 plus 40 into e power minus 0347 into 40. So please, using calculator, tell what is uh, this expression, that is e power, multiply these two numbers and tell.
So final answer 50, sir.
Okay. Final answer 50. Correct. Correct.
Okay,
What is
sir.
your name? Karthikeyan.
Karthik. Yes, sir.
Is correct. Final answer is 50. Correct. Okay. So I think uh, this is, please check it. Minus, I got it 1.38. So t equal to, so this is nearly, I got a 10 point something. So t is approximately equal to 50 degrees Celsius. So before going to the electric circuit, maybe I will solve one more problem in Newton's law of cooling. Third problem. Third problem is okay. When a cake is removed from an oven, its temperature is measured its temperature is measured at 150 degrees Celsius. Okay. 3 minutes later, 3 minutes later, its temperature is 90 degrees Celsius. Okay. How long will it take? How long will it take for the cake to cool off to a room temperature? To a room temperature of 20 degrees Celsius. Okay. So what is given in the question first? So what is TS? Can you tell?
20 degrees.
Yeah, 20 is correct. What is your name?
Parasal.
Parasam. Okay, good. What is T of 0? Initially, what is the temperature of the cake? 150, yeah.
150.
150 degrees.
Okay, yes, correct. And after 3 minutes later, that is the T of 3 is 90. Okay, so the question is how long it will take the temperature for the cake. Initially, it is 150. After 3 minutes, 90. So they're asking, okay, the time, okay, the time at which the temperature of the cake is also 20. That is equal to room temperature. So that is the question they're asking. So when it will attain uh, the temperature of the cake is 20. So that is the question here. So by Newton's law of cooling, anybody got the answer? You can tell to me. Newton's law of cooling, T equal to Ts plus T into e power minus lambda T. Okay, now at T equal to 0, capital T equal to 150. Sorry. Okay, now 150 equal to Ts is given. Ts is 20 plus C. C, I need to find C, e power 0. So this implies C equal to 130. Okay, now substitute C value here. So T equal to Ts is 20 plus C is 130 to e power minus lambda T. So I call this is 1, this is 2. Now at a T equal to 3, T equal to 3, capital T equal to it is given what? 90 degree. 90 degree. Okay, so if you substitute 90 equal to 20, equation 2 implies 90 equal to 20 plus C into e power minus lambda T. Lambda T is 3 lambda. Okay, 3 lambda. So you'll get 70, 70. Here we have 130. So 70 divided by 130 equal to e power minus 3 lambda. So this implies e power minus 3 lambda equal to 7 by 30. 7 by 30. So anybody got the answer? E power minus lambda whole power 3 equal to 7 by 30. I am waiting for your answer. Yeah, please tell.
0.1.
0.0.
Please check it carefully. Dikshita and Yashashwini. Little bit carefully. You need to check it carefully. Any other answer?
11.1 seconds.
No, Subramaniam. You also need to check it. I'm asking the final answer.
3, sir.
No.
Value of lambda.
Yeah, please tell. Value of lambda. Okay, value of lambda is 0.206.
0.206.
Yes.
0.09.
Yeah, lambda is 0.206. Yes. Look at the equation carefully. Pragadesh. Undefined, sir. Very good. Very good. Undefined. Okay. So
It won't reach room temperature.
undefined சொல்றதை விட no finite solution.
Okay, sir.
Okay, it has no finite solution. Okay, okay, okay. That's why I'm waiting for your answer, because somebody will find this answer. So I have your okay. So that's why I'm writing. So usually if I proceed like this, what you are getting, e power minus lambda equal to, okay, that is a 7 by 13 Okay, 7 by 13 whole power 1 by 3. Okay, wow. So this is equal to, please check it. If I done any mistake, please point out. 0.8136. So now this implies minus lambda equal to, okay, minus 0.206. Okay, this implies a lambda equal to 0.206. So once we got value of lambda, substitute lambda here in equation 2. Okay, substitute lambda equal to 2. Equation 2 implies t equal to Ts is 20, C is 130, and e power minus lambda. Lambda is 0.206. 206 into t. Into t. Okay. Now, if you see here, when t equal to what is given the question, we need to find the temperature T at t equal to what? Okay, I want to see the question again. We need to find the temp. Okay, T when capital T equal to 20. So if I put 20 equal to 20, okay, plus 130, okay, into e power minus something, okay. So now this is 0 equal to e power minus 0.20 into 206 into t. This will this is happened. Okay, e power. You know that e is always e value is greater than 0. Okay, so when t approaches infinity, okay, t approaches infinity, what happened? E power minus infinity only 0. Okay, e power t approaches infinity, then you will get what? Here have minus 9. So e power minus infinity approaches 0. So that's why. So from this itself, we can see that when t equal to 30, 20, when, because we need t equal to 20. At what time? At what time t equal to 20? This should be 0. When this should be 0, the exponential is 0. When this exponential 0, so this is approaches 0 only if t approaches infinity. So then only this is 0. Okay. So in this case, you should write. Just I will tell you. Please note down this equation. We call some equation 3. Okay, well, equation 3. Yeah. Okay, equation 3. Equation 3 furnishes no finite solution. Equation 3 has no finite solution to t of t equal to 20. Okay, well, since limit t tends to infinity, t of t equal to 20. Okay, well, but what is time now? Okay, still I have 5 minutes. Okay, so but intuitively you can expect, for example, t. I will take t here. Here I'll take t of t. So this is minutes. When t equal to 0, please tell t of t, and 5, 10, 15, 20, 25, 30. So when t equal to 0, here if we substitute 0, this is 1. So 130 plus 20 is 150. Similarly at 5, substitute here t equal to 5. I got, please check it, 66.41. At t equal to 4, sorry 10, I got 36.57. At t equal to 10, 15, substitute here, you will get 25.92. When t equal to 20, when t equal to 25, 20.75, when 30, 20.27. So approximately with the half an hour, the 30 minutes, the coffee, cake is cools down to room temperature, so 20.27. So you may argue, sir, I'll put a t equal to 60, so I'll get a 20.001. Okay, I agree with you. Even if you put a t equal to 1000, you will get a 20.0000004 something. Okay, because it is given here, when t approaches infinity only, it approaches 0. So I am telling approximately when t equal to 20, 30, the cake will comes to the room temperature, uh, 20 degrees Celsius. So one more sentence you can write. Uh, okay, so the cake will be approximately at the room temperature in about 30 minutes. Okay. So I don't want to start now electrical circuit because time is not sufficient. So I'll give the practice problem to you. So you will try. I think Manigandan solved 13 problems. So still I am not checking because I have some other work. So I want to check it, but I can't. The same problem like you. So you want to extend at least 2 weeks. So I also want to extend, but I can't tell to anyone. So that's a problem. Okay. So the practice problem is first problem. You take an ice cream. Okay. First practice problem. You take an ice cream out of the freezer. Okay. Out of the. So it is better to show the problem to you. Okay. The problem is here. So I don't want to take your time. So please write down. Don't see the solution. You take an ice cream out of the freezer, kept at minus 18 degrees Celsius, full stuff. Outside it is at 32 degrees Celsius. Okay. After 1 minute, the ice cream has warmed to minus 8 degrees Celsius. What is the temperature of the ice cream after 5 minutes? So this is the first column. So remaining two columns I will send through WhatsApp, or otherwise I will send this link to. I will share this link in the WhatsApp group. So tomorrow the class is from 11 to 1. Okay. Thank you. If you have any doubts, you can ask to me now. Otherwise, we'll meet tomorrow. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
சார்
Subramaniam, சொல்லுப்பா.
சார் இந்த லாஸ்ட் ப்ராப்ளம் இஃப் இட் டேக் லாக் ஆன் போத் சைட் சார்.
சொல்லுப்பா, கால் சரியா விட்டு விட்டு கேக்குது. சொல்லு.
சார் லாஸ்ட் ப்ராப்ளம்ல லாக் எடுத்தோம்னா லெஃப்ட் சைடு லாக் 0 1 வந்துடும் சார்.
எங்க log 0 is not defined இல்ல.
ஓகே ஓகே
log 1 தான் 0, log 0 is not defined. ஓகேவா?
ஓகே சார்.
ஓகே, நோ ப்ராப்ளம். ஸோ டவுட் கேட்கலாம் என்கிட்ட. ஓகேவா? தெரிஞ்சா சொல்லுங்க,
Okay, sir.
தெரியலன்னா லக்ஷ்மி நாராயணன் நம்ம டிஸ்கஸ் பண்ணலாம். சரியா? ஓகே, வெரி குட்.
ஓகே சார்.
நாளைக்கு மீட் பண்ணலாம்.
ஓகே சார். தேங்க்யூ சார்.
வேற ஏதாவது டவுட் இருக்கா?
கொஞ்சம் காட்டுங்க.
ஹரிஹரன். ஓகே, ஹரிஹரனா? ஓகே, ஹோம்ஒர்க் ஃபாலோ வந்துட்டு நான் லிங்க் அனுப்புகிறேன். ஓகேவா? இல்லை பார்த்துக்கலாம். இல்லை டேக் அன் ஐஸ்கிரீம். ஓகே, நெக்ஸ்ட் அவர் கிளாஸ் இருக்குங்களா? நல்லா சரி டக்குன்னு
எஸ் சார், எழுதிட்டேன் சார்.
எழுதியா? சரி,
தேங்க்யூ சார்.
நான் குரூப்பில் ஷேர் பண்ணுறேன்.
ஓகே சார்,
தேங்க்யூ.
தேங்க்யூ சார்.
தேங்க்யூ.